Alright, geometry, welcome to part 2 of the same series on reviewing for the final. So we got some similar stuff going on here. Solve for x, each figure is a parallelogram. Quick reminder for parallelograms, opposites are congruent, opposite angles are congruent, opposite sides are congruent, and consecutive interior angles are supplementary. So let's look at this one. We got 38 degrees and 142x. That's two angles in a row, so they are supplementary. That means that we have something plus something equals 180. So we'll have 38 plus 142x equals 180. If I subtract 38 from both sides, we get 142x equals 142. So when I divide both sides by 142, x equals 1. That was a nice, easy, breezy, lemon squeezy problem. Let's move on to the next one. We'll do this one in red. Okay, so we got this x and this y angle here. It's split up into three parts, but it's really two angles that are supplementary. So again, we're going to have something plus something equals 180. So the first thing, I'll put x in this first one here. We got 61x plus 1. Then I have the other two pieces, 28 and 29, so I have to have 28 plus 29 equals 180. So let's simplify now. 61 plus 1, or pardon me, 1 plus 28 is 29, so then I got two 29s. That's going to give me 58. So 61x plus 58 equals 180. So I got to subtract 58 from both sides. Then that gives me 61x is equal to 122. Conveniently, if I divide this, it goes in twice. X equals 2. And again, right now, all it's asking us to do is solve for x. So let's do one more problem very similar to this. We find out that DF is 32. And this is a parallelogram, so that means that these pieces are split in half. DH and HF are the same. Similarly, CH and HE are also the same. So if DF is 32, then that means this half would be 16 and this half would be 16. And that's actually really helpful because it's asking me to find HF right there on the bottom right. So I know that 6x minus 2 is just half that full length. So that's 16. Now if I add 2 to both sides, I can simplify this. We get 18 equals 6x, and dividing by 6, x equals 3. Awesome. Let's keep on keeping on. This next one, mid-segments. I like to call it the average segment because it's the one that's the average of the other two. You have two other numbers and you're trying to find the piece that's right in the middle. So this part here, LK, is going to be the average of the top and the bottom. So basically if I take the top plus the bottom divided by 2, that's going to give me the middle. Well, the top is 19.1 and the bottom is 10.9, and when I add those two together, let's see what we get. That's going to give me 30 divided by 2, so the exact middle is going to be 15. That's the average, 15. This next one is the same idea, it's got some algebra in it, so that steps up the difficulty just a tiny bit. So we got a top and a bottom. So it's the top plus the bottom divided by 2 equals the middle. So the top is 2x, the bottom is 16, and then we're going to divide that by 2, and that equals the middle, which is 5x minus 16. Now here, I just need to really do some algebra. Let's get rid of this denominator first. I'm going to multiply both sides by 2. Notice that on the right side, this 2 is times multiplied by the whole term, not just part of it, not just the 16, but also the 5x. So when I simplify that, that gives me 10x minus 32. On the left side, I'm left with 2x plus 16. And these are equal to each other. Okay, so let's rewrite that kind of over here. I'm starting to lose some of my space. So that means that I'll have 2x plus 16 equals 10x minus 32. I'm going to add 32 to both sides. And I'm going to subtract 2x from both sides. That's going to give me 8x here, and also 8 and 4, 488 on the other side. So if I divide both sides by 8, That'll simplify to 1 on the right side, and x is equal to 6. Now, is that all it asked me to do? It said find the length. The mid-segment is this piece here, the 5x minus 16, that xw. We know that x equals 6. That's really 5 times 6 minus 16, or 30 minus 16, which is 14. And that's it. That wasn't too bad. Okay, so those are the other ones. Let's keep them. We want to move back. We've got plenty of space to work. Alright, again, solve for x. We got trapezoids talking about the middle. Here's our top, here's our middle, here's our bottom, and we know that the top plus the bottom divided by 2 equals the middle. The average of the top and the bottom equals the middle. So let's do that. Solve for x. We know that 10 is our top plus our bottom is 26 divided by 2 equals negative x plus 30. So we got 10 plus 26, that's 36 divided by 2 equals negative x plus 30. Okay, 36 divided by 2, I can simplify that. That's 18 is negative x plus 30. I'm going to add x to both sides. Add x, and I'm going to subtract 18. Gives me x equals 12. And that's all it was asking me to do, is to solve for x. Let's do this next one. It's pretty similar here. We'll do it in a different color. How about blue? So we're going to take the top plus the bottom divided by 2, and that's going to give us the middle. Top plus the bottom divided by 2 equals the middle. So 22 plus 2x plus 38, all divided by 2, is equal to this middle, which is 30. Let's go ahead and just get rid of this 2 by multiplying both sides by 2. Because 2 over 2 is just 1. That means that I have 22 plus 2x plus 38 is equal to 60. So now I need to figure out what this is going to simplify to. If I have 22 and 38, that actually equals 6. Some more space. So that means 2x plus 60 equals 60. Now something should be going off in your head that says, ooh, this is kind of weird. Because when I subtract 60 from both sides, I get 2x equals 0. Well, that must mean then that x equals 0. That occasionally does happen, as it does in this case. 0. That's an okay answer. It's a number, just like any other. Let's look at some more. 3 and 24, and these again are trapezoids, but notice there's something a little bit different about these ones. Now we're looking at isosceles trapezoids, where these two sides are congruent. Those two legs are congruent, and if they're congruent, then that means it's isosceles. And if it's isosceles, it's got symmetry. And the bases are parallel. So those are the properties that are going to help us figure out this shape. So that means this Q and this T are actually the same. So this other side on the left is going to be 55 degrees, just like the right. And R here is the same as S. I'm not going to need that one because now I have two angles here that come from parallel lines, and that's going to give me a supplementary relationship. So S and T are supplementary. And if they're supplementary, that means that I have two pieces that are going to add up to 180. So I got 127x minus 2. Let's put that in the bigger one here. And then 55. So I got to do some simplifying now. We got 55 minus 2, that's 53. And 127x. If I subtract 53 from both sides, 127x equals 127. How convenient! Another easy problem. When I divide both sides by 127, x is just equal to 1. Is that all it's asking us to do? Yep. Just solve for x, and then you're done. Let's move on to a new color. How about back to black? Here we go. We're finding measure of angle W. So that's different. That's not just solving for x. Now we're going to find a measure, which means we need to plug back in. At the end, we go into the expression. Okay, so and W is the one that we want. Notice again we have congruent legs, which means that this is isosceles, which means there's a sense of symmetry. So x and y are the same. So that means this side is 16x plus 2. Now these two angles inside parallel lines right here are same side interior angles or consecutive interior angles. That means that they are supplementary. So we have something plus something equals 180. So I'm going to have 16x plus 2 and 8x plus 10. Now if I add all that together, I'm going to have 24x plus 12 equals 180. So let's subtract 12 from both sides. That gives me 24x equals 168. Is that correct? It looks like it. So let's divide both sides by 24 and see what we would get. Now I have a calculator just to speed things up here again. So we got 168 divided by 24 equals 7. X equals 7. I should have been able to do that, but had my calculator handy just in case. Alright, we're at 24, 6 more to go, and we'll be done with part 2. Now we're being asked to find the area for each. When I look at these, this is a parallelogram, and the area of a parallelogram is equal to just the base times the height. Well, the base is 5, so I got to determine which of these two numbers is the height. This one or this one. The height and base are always perpendicular to each other. So the one that would be perpendicular is this 1.7. So that means I have 5. The area is going to be equal to 5 times 1.7. So 1.7 times 5. What would that be? Well, let's just do that one by hand. 5 times 7 is 35. 5 times 1 plus 3 is 8. And we have a decimal point here, so it's going to be 8.5. So the area here equals 8.5 centimeters squared, or square centimeters. This next one's a little bit hidden. We have information, but we don't have a picture, and we don't have all of the work prepped for us. That means we have to do some preparation. So if we're given a circumference, we need to remember that the circumference equals 2 pi r, or 2 times the radius times pi. It's also equal to pi times the diameter, if you want to think of it that way. I tend to like the radius, but whatever. Okay, so 2 times pi times r. So why do I need to know that? Because I know that the circumference is 20 pi, and that's the same as 2 pi times whatever the radius is. If I use this relationship and I divide both sides by 2 pi, pi over pi is 1, so those disappear. 2 over 2 is 1. 20 over 2 is 10. So that's what the radius would be. But the area of a circle is pi times the radius squared. So in this case, that'd be pi times 10 squared, or 100 pi. That is our actual answer for the area. All right, again, remember, if you need to slow it down, pause the video, move on. But I'm going to keep moving because I want to finish. All right, for this next piece here, it says find the missing measurement. So we got to look for a relationship, some type of area, and then set it up and solve. Set it up and solve. So we're going to set up the equation, and then we're going to solve for the missing piece. So first, let's look at what we got. I see a triangle, and the area of a triangle is equal to half the base times the height. So let's replace the pieces that we know. We know that the area is 9.5. We also know that we have a half here. And we have a base, which is kind of a question mark, and then this height, which is 3.8. So if I wanted to kind of simplify this, I need to take half of 3.8. Well, let's take our calculator and do 3.8 divided by 2. That's 1.9. So we got 1.9 times something, call it question mark, is equal to 9.5. So if I divide both sides by 1.9, that should simplify down to what I need. So 5 divided by 1.9. 5. That's exactly 5. So 5 equals our question mark. That was easier than I thought, or more exact than I thought I should say. 5 yards, by the way. But it's just 5. No rounding necessary. Number 28. All right, now we're getting to the interior angles. It says one exterior angle. All right, this says it doesn't really say it, but this is a regular polygon where we have all these angles are the same going all the way around. So we just need to count how many there are and then come to some common sense as well. Notice that we start pointing this direction. and we slowly rotate until we're back to that direction. So we did one full rotation, and that's 360 degrees. So if we take 360 degrees and divide it by the number of rotations we did, we'll find one of them. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9. That's like 9. So I'm going to divide that by 9. 9 goes into 360 40 times. So it's 40 degrees. That would be our answer. Each of these is 40. Because if we add that up 9 times, we're going to add up to 360. Let's look at another one that's similar, but not 9 here. It says find it for each polygon. Now, two things are different here. First, it's finding a sum. Second, it's finding the inside, which is significantly greater. I mean, look at this one angle here, and we got a whole bunch of them. All right, so let's start by picking a corner. I'm going to pick this one right here where I made the dot. Now, I'm going to use a little bit of a straight line tool. You guys could use a ruler for this. That might be helpful. I'm going to draw triangles in here. I got 1, 2. I'm going to fan them out from that one dot all the way around. 1, 2, 3, 4. 5, 6 lines, 7 lines, 8 lines, 9 lines. Okay, so I got a bunch of triangles all the way around. So now I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I got 10 triangles. And in each of those triangles, inside a triangle, the sum of the angles is 180 degrees. So I'm going to have 10 times 180. So the total, then, is going to equal to 1,800 degrees. It's not as bad as we think. You know, if you just think about splitting it up into triangles, it makes it a lot easier to calculate. Final one, actually we're skipping number 3. So to stop this video here and come on back for part 3.